Hey, welcome to 49cc Scoot. My name's Brent. In this episode, I'm going to be installing a programmable Stage6 PVL ignition system and showing you my experience with it, including some setup tips. If you watch my videos, the last time you saw me working on the 94cc RC1 was when I swapped the 28mm Del Orto VHST carburetor out for a 34mm Polini PWK. It was a struggle to say the least trying to get it in a safe state of tune. I started with the usual jet and needle changes, but my exhaust gas temperatures were very high with jets commonly used by others with big PWKs on these engines, even reaching a piston scorching 1400 degrees at times. At one point, I had to use a main jet that I drilled to 2.5mm, or roughly a 250, to lower EGT to acceptable levels, but performance fell off. I went through tons and tons of jetting tests, needle swaps, verifying that my EGT was functioning properly, and I even borrowed an identical carb from a friend, and it did the same thing that mine did. I put the 28mm VHST back on for a sanity check of sorts, and it ran just fine with the same tune and same EGT that I was used to prior to the PWK. A more sensible person would probably leave the 28mm installed and just carry on with life happily ever after. But I just had to know why the PWK is so difficult for me to tune and seemingly so simple for everyone else. Eventually, I advanced the timing on my MVT ignition by 3 degrees, and that was the first change that I thought was real progress, because EGT fell into the range that had worked well for me in the past with much smaller main jets. I dialed it in with a 190 main jet, which is in the ballpark of what others seem to use. But once I fine-tuned the CVT to keep it around peak power during acceleration runs, it started showing 1300 EGT by the end of an 1/8 mile. I moved up to a 195 main jet to see if that helped, and not much changed. But on the way home from test runs, I ran it up to near 70 miles per hour leaving a stop, and the engine died as I let off. It ruined the piston, and I had to clean aluminum transfer off of the cylinder. I waited more than 3 months with a new C-piston on order from Malossi with no action before finally giving up and finding a BB piston in stock, which is 0.005mm smaller than the C that I was trying to get, and likely of very little consequence. I was actually much further from Malossi's stated clearance spec when the kit was brand new. I got the engine back together, but since the piston failed as I was rolling out of the throttle, I thought that the MVT's ignition curve may be to blame. It was aggressive using the manufacturer's suggested spec anyway, but by the time my entire curve was advanced 3 degrees, I had as much as 45 degrees of advance at lower RPM, and that's quite a bit. The curve can't be changed, only advanced or retarded as a whole by stator and rotor adjustments, unless you use MVT's EEPROM replacement CDI with a handful of selectable curves that I really didn't like either. I wanted to try the same timing that Malossi would provide with the full RC1 kit, so the obvious choice would be to get their MHR team ignition. But Stage6 released their RT programmable PVL ignition, and that would allow custom curve creation. It was more than $100 over the price of the MHR team, but I justified it to myself with the hope that it's somewhat future-proof, since I could make whatever curve I want, and it could be fine-tuned to exactly what works best for each setup. I didn't see a listing for a C1 or RC1 version of the ignition, so I picked up the model for Piaggio 2-strokes. It includes a flash drive, USB cable, programmer, CDI, coil, hardware kit, mounting plate for Piaggio engines, ground strap, stator, rotor, stickers, and instructions. I also got a 300-gram flywheel weight in case I needed it, and so I can test with and without it at some point in the future to see which does best for 1/8 mile runs. If you're looking for an ignition of your own or any other scooter parts, check out scootertuning.ca. Most of the parts on my scooters come from these guys. Even being in Canada, shipping to me in the US is as fast and affordable as anyone that I've dealt with, and they support this channel by giving me discounts on parts. That's a big help, because being a scooter YouTuber at my level is not exactly a well-paying venture. But getting a little break on parts makes it possible for me to continue what I do. So please support businesses that continue to support the scooter community, and go check out scootertuning.ca. I weighed the MVT and Stage6 rotors and the flywheel weight, and also noted their outside diameters, because where the weight is also important. The further away from center that mass is, the greater the rotational inertia it will have. Now, calculations of this are beyond my scale, but it's clear that the PVL's rotor, when used alone, should provide the most responsive engine. The MVT is somewhere in the middle, and the PVL rotor and weight combo should by far have the greatest moment of inertia and resist change the most, which could smooth throttle response and possibly be good for some speed and RPM in some cases. It's also interesting to me that the advertised 300-gram add-on actually weighs 380 grams. And I don't think it's just an error with mine, because I noticed sellers listing the packaged weight around 390 grams. When it was time to install the ignition, I assumed that I needed to use the adapter plate, as I've always had some sort of backplate with other ignitions. But it didn't fit within the recess in the case, and if I simply bolted it on, the rotor couldn't sit far enough in on the crank. I cut my plate with a mini lathe till it fit the cases. Then I saw that for the stator wiring to align with the cutout in the plate, it would have to be in a position that wouldn't allow it to fit or be adjusted properly unless the case was modified. That didn't make sense to me, so I looked it over and then wondered if I could mount the stator directly to the case. The mounting holes were the same on the adapter as the case, so those worked fine, and I noticed that the clocking of the stator shown in the Piaggio assembly instructions worked best for the RC1 as well. The PVL rotor uses a woodruff key, just like a stock ignition, making it easier to install than the MVT that mounts without a key and requires timing checks to ensure proper orientation. I used a 3x5x12mm key from a Harbor Freight kit, but standard Piaggio and even Minarelli keys should fit the Malossi crank. I torqued the rotor nut, not supplied, to 32.5 pound-feet, and alignment of the stator and rotor looked pretty much perfect. So mounting the ignition to the engine was actually incredibly quick and easy, but Stage6 included instructions dated February of 2011 with no information about RC1 engines. For what these things cost, it would be nice if updated instructions were supplied. A quick paragraph and a picture or two would cover it. The stator marking still needs to be set to align with the rotor mark at a specific point, and this is the most difficult part of assembly. I'll cover it here, but if you want to see more detailed info about setting up race ignitions, check out my videos linked in the description. Stage6 provides specs in millimeters before top dead center for commonly used stroke and connecting rod lengths, so step 1 is to determine which one you should use. My engine has a 44mm stroke with a 90mm connecting rod, so I needed to align the marks at 3.59mm before top dead center. I want to note that not everyone's engine combo will be covered here. For example, the Too Fast 100cc for RC1 has a 47mm stroke and 100mm connecting rod, which isn't listed. I did the math for all of the listings provided by Stage6, and they average about 29.85 to 29.86 degrees before top dead center. I've got calculators on my site specifically for converting millimeters before top dead center to degrees before top dead center, or vice versa. So if you've got an unlisted combination, then click on the link in the description and enter your crankshaft specs along with 29.86 degrees, and it'll tell you how many millimeters before top dead center is required to reach that timing. I use an adapter that I made and a dial indicator to measure piston depth from top dead center, but you can use a special micrometer made for the job if you prefer. The dial indicator is zeroed at top dead center, the highest point of travel in the bore. Then, I rotated the crank in the direction that it would rotate when running until the indicator showed 3.59 millimeters. You have to be very careful to go to the spec before reaching top dead center and not after top dead center. The stator has 2 timing marks on it along with 2 arrows. The timing mark on the rotor should align with the mark on the stator that has an arrow pointing in the direction of travel. Again, clockwise for this and most scooter engines from the stator side. Mounting bolts are then loosened enough that the stator can be rotated to make the marks align. Then, the mounting bolts are snugged and the alignment is double checked to be sure that it coincides with the specified 3.59 millimeters before top dead center in my case. I removed the bolts one by one and applied thread locker before reinstalling. Wiring is routed around the outer edge to the cutout in the case and sort of wedges in place, but I also added zip ties later. I believe some kits come with an anodized part, but this one just includes a foil sticker. I wanted to be able to check timing with a light, and indicators that I made before were too large to work with a PVL's tiny rotor, so I made a new indicator. The coil includes a plug wire but no cap, so I installed an NGK LB05E-R, which is a 5000 ohm resistor cap for plugs with terminal nuts. Next, I needed to make the electrical connections. The wiring is pretty straightforward, with one connector joining the CDI and stator, a ground wire, coil positive, and ignition disable or kill switch. There's also a green wire that can be grounded to switch between the 2 curves that Stage6 provides, and one connection that's used for programming the CDI. Stage6 supplies a ground strap to ensure a strong ground between the engine and frame. And while it's never a bad idea to ensure a good ground connection, I didn't use it because I always connect the frame, engine, and battery negative terminal with cables at a single point, so I can be sure that everything is well grounded. And I put a couple of different frame grounding points in my wiring harness's ground for good measure as well. I removed the connectors from the stator and CDI coupling points, extended the wires from the stator to reach my CDI, and then installed sealed connectors on each. The supplied connectors could be reused, but I didn't have the right terminals for them and didn't want to add more solder points than I had to. I also cut the connectors off of the coil and kill switch wires from the CDI and used the connector to match what's on my harness. The ground wire was attached to the frame where the CDI mounts with a vibration isolator. Vibration isolators are cheap and they reduce the risk of CDI failure. At that point, my new ignition was installed, so I replaced the 195 main jet with a 200, and I moved the clip on the needle down to add fuel to the tune for a safety margin before trying to start it. Weak kicks got me nowhere, and strong kicks only sometimes gave puffing sounds and sometimes a half second where I'd think it was trying to start. I've had ignitions that were too far advanced backfire or pop or kick back, but this was a little different. There was minor kickback at times, but the sound was more of a puff than a pop. I thought my best bet was to retard the timing by rotating the stator and see what happens, so I backed it off a little bit. That didn't work, so I backed it off as far as I could. I got a lot of empty kicks and a puff, but then it fired up. It sounded good, and I even made sure that it moved forward with throttle because two strokes can start backwards and take off in reverse. The problem is, it wouldn't start again after that, even with moving the timing back and forth in both directions. The CDI has two ignition curves that can be selected by switching a ground on or off of the green wire. With no ground, it uses the circuit racing curve, and with a ground, it switches to a drag racing curve. Of course, they don't supply you with graphs of these curves or any useful information aside from what they recommend them for. As a shot in the dark, I grounded the green wire to use the drag racing curve, and with the ignition all the way advanced, it started again. Then went right back to refusing to start regardless of where I moved the stator or which curve was used. More parts arrived at that point, so I moved to a related test to give my legs a rest. This ignition system has no charging or lighting output, so all accessories have to rely solely on battery power, and there's no need for the regulator rectifier. Constantly draining and recharging standard motorcycle batteries is going to severely shorten their lifespan, and I wanted a solution that would let me ride for hours without having to carry a bunch of big heavy batteries around. I was looking at lithium iron phosphate batteries for power supplies because that's what my friend Ryan uses for his total loss ignition, and they work well for him. But Sinful from the 49cc Scoop forums suggested trying power tool batteries instead. I already had batteries for my Milwaukee 18-volt tools, so I picked up an adapter for quick connection and a 12-volt step-down regulator for around $30. I spent a bit of time looking at regulators because they come with different voltage and current ratings, and this one is supposed to be good for up to 30 amps and input up to 40 volts, which should be way more than I need. I cut a piece of 3/16 inch ABS and made a battery compartment cover out of that. Then the battery adapter was mounted to it, and wires were routed through holes with rubber grommets to protect them. Wiring is pretty simple, with one pair of wires, black and red, going to the drill battery, and the yellow and black pair going to the scooter's wiring harness, just as a motorcycle battery would. Now a battery slides in and the regulator does its job with my voltmeter showing 12.0 volts even with the headlight and water pump on. While testing, I noticed that my voltmeter would change voltage as I moved the key, and that my key had a lot of play in the on position. That got me thinking about the starting issues again, and wondering if the ignition could be malfunctioning at times on the kill circuit side and causing starting problems. So I did resistance and continuity checks on it and the kill switch, but I never saw any sign that either was supplying a ground to the kill circuit to disable or interrupt the ignition. I still ordered another ignition switch and replaced it later, But it wasn't causing my problem, so I set the ignition timing to roughly the center of its adjustment and installed the flywheel weight. The extra mass did get it cranking over better when kicked, but it still took many attempts before it fired up. Since it started, I left it running and took it down the road for a very brief test ride. It was way rich at low throttle positions, but would clear out with more throttle. Within a mile, I started hearing a metallic noise, which turned out to be the flywheel weight coming loose. I couldn't tighten it while running, but if I shut it off, it may not restart. But I'd probably lose the weight if I tried to make it back, and I really didn't want over 3/4 of a pound of steel flying at me after being ejected at high RPM. Yeah. Alright. I tried and tried, but it would not start. The kickstart was really slipping a lot by that point, so I took it apart for a look when I got home. The teeth on the kickstart shaft were chewed up and other parts weren't perfect, so I replaced all of the gears and springs. I started doing some checks while waiting on the kickstart parts to arrive, starting by setting the timing back to the manufacturer's spec at 3.59mm before top dead center. I set up a degree wheel as well to make sure that nothing was way out of whack, but it looked like 30 degrees at 3.59mm, and it's supposed to be 29.86 degrees based on the math for stroke and rod length. 0.14 degrees is essentially nothing, and it's pretty doubtful that my measurements are even up to that level of precision. I found a troubleshooting guide from PVL, and it recommended using a resistor spark plug cap and a non-resistor plug for their digital ignitions. I typically use these resistor plugs, designated by the R in their part numbers, so I looked for their non-resistor counterparts without the R, but they're pretty hard to come by, so I'm just using iridium since PVL suggests fine wire or precious metal plugs as well. I checked the coil's secondary resistance, from the blue coil positive wire to the end of the plug wire with the cap removed, and it was in spec. I couldn't find any info on the 1042 stator, but at 89.8 ohms, I assumed it was in spec for a digital stator with 3000 windings. I also went over some basics and checked the reed valves. Parts came in, so I replaced the kickstart stuff and then set up an indicator so I could check the timing. The indicator that I made earlier doesn't work well with the weight installed, so I just spaced out the indicator that I had for the MVT ignition. The new kickstart parts and the ability to get a better kick helped a lot to get it running, and then I ran it up through the revs with both ignition curves and reviewed the video to collect timing data. The first thing that I noticed is that it appears to be at 30 degrees advance while trying to start. The instructions that come with the included timing software have this to say. During engine cranking/starting, the spark will occur at the hardware ignition point. In this time, the Andromeda software curve has no influence on the ignition timing. Therefore, a mechanical adjustment of the hardware ignition point can be performed to achieve good engine starting behavior. From what I've seen in the program, mechanical timing, which is where the stator is set up, is where advance is until about 600 to 800 RPM. So my timing is at 3.59mm before top dead center, or roughly 30 degrees, and that's what I saw when kicking. I don't imagine that this has a positive effect on starting, because starting should be easier with less advance, but that's not the only issue. The other thing that I noticed is that there is no spark unless I got a good kick. I'm not sure exactly how much RPM it needs, but I would say at least somewhere in the 300 to 400 RPM range. So the worn out kickstart parts were not doing me any favors. I still think the MVT was superior for ease of starting, but I had much less trouble once I could turn the engine over faster. Now let's look at the curves. These are the curves that I observed, adjusted for timing light discrepancies, which I'll explain soon. There's a lot of advance at lower RPM, which I'm not totally mad at, but still about 10 degrees more advanced than I expect to work well for me in the power band. The big surprise to me is that the drag racing curve has less advance at low RPM than the road racing curve. I don't know much about road racing requirements, but I would expect drag racing curves to be the most aggressive with advance at low revs, because generally you'll be on the throttle hard for maybe 1/8 of a mile or 1/4 of a mile here in the US, and then out of the throttle after. There isn't typically a lot of mid-throttle for drag racing, aside from maybe trying to keep the bike in shape with the front down to takeoff. So you should be able to get away with higher advance at low revs to get the bike moving as quickly as possible off the line. I think that road racing should be much more comparable to street riding, where you may need to use part throttle to navigate the winding course. So less advance below the peak power band would make detonation less likely. It seems like either these curves are mixed up, or I have no idea how any of this works. Both are plausible. Unfortunately, I haven't found these curves published anywhere to see if my curves are anywhere near what is specified. A friend of mine named Zach Gillette also used this ignition for a while and contacted Stage6 to see if they would share the curves with us. And he was told that the curves are on the flash drive that comes with the ignition. There were 5 ignition maps in a folder named Curves, and I made sure to check all folders on the drive to see if more were hiding in there, but this is all that I found. Nothing matches up, so Stage6 was contacted again for clarification, but they would only say that they were on the flash drive and then didn't respond anymore. The nearest match to what I observed is the 598 standard 5000 winding curve, but the timing was off, so I added 15 degrees to see how it looked with the others. It's not way off once adjusted, but it's still definitely not the same as either of the two that I recorded. The only way that I see this being correct for one of them is if there's some sort of delay happening in the processing of the signal that changes the curve, or if my adjustment for timing light delay is wrong. Regardless, it sure would make life easier if Stage6 would just label the curves drag race and road race, or mention whatever is supposed to match up in their instructions. Now let me tell you how I found the correction factors for my timing light, as well as some more info on getting the observed timing to match the programmed timing. The first time that I tried a custom curve, I checked timing and realized that it was off, so I ended up needing to find a simple way to check programmed versus observed timing. I made a curve that was 16 degrees flat across the entire RPM range. It could be basically any number that would let your setup run well enough throughout the rev range, but Malossi specifies 16 degrees for the RC1, so I used that. Then you just need to load the curve into the CDI and see what you actually get with a timing light. In my case, I had already seen that timing was roughly 6 degrees off of my expectations and set my stator accordingly, moving from 3.59 millimeters before top dead center, which is 29.86 degrees, to 5.1 millimeters before top dead center, or 35.87 degrees, for 6.01 degrees more advance. That setting gave me this curve. I guessed that the flat patch from 4,000 to 7,000 RPM is the correct timing, because 2 different timing lights gave me the same reading in that area. And I also found that Malossi specified 4,000 RPM as the point to check timing in one of their ignition manuals. I'm sure that part of the reason for that is because the curve on that particular ignition was staying flat in that range, which makes stable reading much easier than checking anywhere that the timing is ramping up or down. But I also assumed that they must expect timing lights to be accurate at that RPM. I admit that there's a lot of assumption here, but adjusting timing using this method has led to finding peak power basically where I'd expected to be and overall good results. In my case, it looked like it was still a half a degree off, but after already adjusting the timing once, I decided to make changes the easy way and account for that half a degree when I made new curves in the program. Even though I managed to make it right, I don't understand why my timing was off by so much from what I programmed, even after going over the documentation from Stage6 and the Andromeda program that's used to make the curves. But as long as I can wind up with what I program being what I see, then I guess I'm fine with it. I would suggest doing a flatline check like this and observing it as accurately as you can. So let me show you how I did it. I have the luxury of having access to multiple cameras, so I made use of those with one camera set up as straight on as I could get it, with the rotor and timing indicator, and zoomed in tight. That allows me to look at the camera to get a view that never changes angle from the time I'm setting up the timing indicator till I'm running the engine and timing light, because viewing angle changes will cause reading error. I switched from my homemade indicators with etched lines to a printed 360-degree protractor attached to one of the indicators, which allowed me to see things with greater detail and eliminated potential errors in accuracy from my etched lines. During setup of the indicator, I'd suggest checking multiple spots when you're finding true top dead center for zeroing the indicator. I won't go into detail in this process because I have videos all about finding top dead center. But if you set up a degree wheel on the other side of the engine as well, you can verify that multiple points are aligning where they should be. For example, if your indicator isn't correct from being printed in the wrong scale or positioned wrong, you may see that, say, 10 degrees before and after top dead center match expectations. But by the time you get to maybe 40 or 50 degrees, they may not. So checking in multiple locations eliminates another potential inaccuracy. I put another camera on my tach, so I can film the engine RPM and the timing marks at the same time, and then sync those videos, allowing me to scrutinize timing later in an editing program instead of spending tons of time holding RPM up on the bench. Alternatively, you could mount a tach beside the timing indicator and try to catch it all in one shot without needing multiple cameras. I'm certain there's still error in my measurements to some degree, but at least I can say it's not for lack of trying. Thinking about the pre-installed road race and drag race curves again, this made me wonder if they were intended to be what I found or if they're wrong. But I think they're probably as intended, because 5.5 to 6 degrees more advance on those curves would make them very aggressive, and everything was installed exactly to spec and timing was checked multiple times. If anything, I would think that they should be retarded more for suitable advance in the power band. But since Stage6 wouldn't answer questions or publish what they're supposed to be in any of their instructions, all I can do is make guesses. Okay. Now that I've jumped around and covered some of the intricacies of getting this ignition installed and working as you'd expect it, let's talk about some test rides. My first real attempt at a test ride was done with the road race curve and the stator retarded as far as it would go without removing the woodruff key and repositioning the rotor. My total range of adjustment was from 6.5 to 1.84 millimeters before top dead center, or roughly 20 degrees of movement. My goal was to move the timing in the power band of the road race curve down from roughly 26 degrees, closer to what worked better with the MVT at around 17 degrees. But I didn't have enough adjustment and calculated that 1.84 millimeters before top dead center, the edge of the adjustment that I had, should put it within roughly 0.3 degrees of my target, so I called that close enough. The response felt softer than usual, but once I gave it more throttle, power seemed to be there, and everything was fine for the first 4 miles. Then this happened. Luckily, it did restart later, and looking into the exhaust port showed some scuffing on the piston, and a bore scope showed a very clean crown, like it wasn't getting enough fuel. The piston only had 6 mostly easy miles on it, so it shouldn't be coated with much carbon, but it was really clean. I later checked my timing, and it wasn't even close to where I anticipated it to be, and I have no idea why. If you want to move X degrees one way or another, and calculate that distance in millimeters before top dead center, it should be a pretty straightforward process. But this was the second time I moved the timing on the preset curves, and it didn't go where I wanted it to. I had much better luck later with programming my own curves, as I mentioned earlier with the flat curve used for dialing it in. But the preset stuff seemed to move wherever it felt like. I'm sure I'm missing something there, so if you know why the programmable CDI would be predictable once custom curves are entered, but unpredictable with the presets, then please enlighten me in the comments. I'm going to wrap this one up here with the conclusion that ignition timing at lower RPM doesn't seem to be the total cause of my PWK nightmare. But since the video is largely about the Stage 6 programmable PVL ignition, let me leave you with my impressions of it. Having used it now for many months, I'll say that the starting isn't as bad as I initially thought it was, as long as I use the weight disc on it. Anytime that I take the weight off, it goes right back to being tough to start. It's very important to get a good kick. Half-hearted kicks will go nowhere with this thing, so don't try to rip the lever off, but it needs a solid kick with a well-functioning kickstart. Once I started programming ignition curves myself, I like the PVL a lot more. Again, it responds as anticipated that way for whatever reason, and making your own curves lets you adjust timing to find peak power, soften it up or make the power come on quicker, back it down if you have a spot where you get detonation, or basically whatever you want to do with it. In the long run, I really do like the Stage 6 ignition, but I will say that multiple people have told me that the MVT is junk, and I just don't see it. If you take away the ability to program the Stage 6, I think I'd rather work with the MVT, and if MVT would put out a programmable CDI, I think it would be a winner. And let's not forget that the MVT provides power for charging and lighting, though to be honest with you, that's not the game changer that I thought it was. It's a little nicer, but the power tool batteries work quite well. The main thing that I've found to watch with the power tool batteries, or at least the Milwaukees that I use, is that they normally communicate with the tool to shut down for low voltage. When they're on the scoot, they won't shut themselves off when they get into the danger zone, and I've ruined a battery that way, which is not cheap. Alright, now it's really time to end this one. So please like the video if you've enjoyed it or found it helpful, and make sure you're subscribed with notifications turned on so you don't miss future episodes. Thank you for watching.